All right. So how do y'all feel about Newton's second law type problems?
Should we practice?
We just did.
No, wait, more.
We're going to do more. Okay. Those were some pretty easy problems. F equals ma problems. And remember, if you don't know the answer to the question, what do you do?
Yes.
Okay, good. All right. Another great application of Newton's second law is the weight equation. So, Newton's second law says that force is equal to mass times acceleration. If you are talking about weight force, so I like to say that together, weight force, because that reminds you that weight is a force. So weight, your weight, when you get up in the morning or whenever it is that you weigh yourself at the doctor's office, you stand on the scale, and then there's springs in the scale that actually get scrunched up because of your mass being accelerated by the acceleration of gravity. There is a force on the scale. It is your weight force. So when we are talking, this is in general, F is equal to ma, but specifically, if we're talking about your weight, we're talking about it in the context of the acceleration of gravity. Your mass times the acceleration of gravity. Now, these two formulas look very similar because this is just a specific application of Newton's second law. It's specific because we're talking about the acceleration being the acceleration of gravity. And we talk about the acceleration of gravity so much, so often in physics that it has its own little symbol, g. G, if you see the letter G, you may not be told what the value is. You are supposed to know that G is equal to 9.8 meters per second squared. That's an acceleration, right? Meters per second squared. 9.8 is the value of the acceleration of gravity. Meaning that when I drop this marker, what's going to happen to the marker?
Gravity's going to pull it down.
Gravity's going to pull it down. Is it going to leave my hand at a certain speed and then stay at that certain speed? No. It's going to leave my hand at a very slow speed, and then it's going to increase in speed by accelerating. Correct, right? So when I drop this, it speeds up, right? So it speeds up, it accelerates at that rate, 9.8 meters per second squared. Yeah.
So what I'm thinking about is like in skydiving, you know how like you do like this, like you go slower. So like if you like narrow yourself down, you go faster. It's like when you like thin yourself out and like decrease like air resistance. It's like you go as fast as like 9.8 meters per second squared.
No, because there's other forces involved. So you have to look at the net force. We're going to talk about that in just a minute. In fact, it follows this lecture. Just hold on just a minute. I'm going to jump right into that, but I want to make sure everybody understands the weight equation. So if you're asked for a weight and you're given a mass, but you're not given anything else, you're supposed to automatically know if we're talking about weight, we're talking about your mass times the acceleration of gravity, and that acceleration is 9.8. Okay, there were some questions that came up in one of the worksheets. You're like, Mr. A, they haven't given us enough information. You're supposed to know this information. Okay, so if you haven't written that somewhere on your notes where it says the weight equation, you want to write down G is equal to 9.8. Okay, so I am about 80 kilograms. My mass is about 80 kilograms. What is my weight? Can anybody tell me?
9.8.
9.8 times 80, right? 9.8 is pretty close to 10, right? Okay, can we just say, what's 10 times 80? What would 10 times 80 be? 800. So, I'm about 800 pounds, right? No, I'm about 800 what?
Weights. Gravity per second. Acceleration.
What are the standard units for a force? Newtons.
Kilograms.
Right? No, I'm 80 kilograms, but when you convert that to newtons, you guys just aren't used to hearing people's weight force as a large number, but it's a large number because the units are newtons. Right? So I'm about 800 newtons. And newtons doesn't mean anything to you, right? Right? How many pounds is that? So I'm about 170 pounds. To put that into, I wish, on a good day, 170 pounds. 170 pounds.
I was like 70.
170 pounds. Yeah. I'm between 170 and 180. I need to lose it. I need to get down to 170. Okay? So, but in standard units, I'm 800 newtons. Okay? Yeah.
What about like joules?
That's a unit of energy.
Oh.
We're going to get to that in about December.
Okay, where do we put this?
Can I answer some more questions for you? Let's talk about weight and mass for a second. So somewhere along the line, you should have written down some vocab. Weight is a force which depends on the acceleration of gravity. Weight, when you stand on the bathroom scale, the scale reads your weight. It reads how your mass is being accelerated by the force of gravity. Okay? Mass is how much matter there is in an object. Right? There is a relationship. Weight is proportional to mass. Do you guys recognize this little squiggle I wrote up here? It is a symbol for proportionality. It's a proportion. But that means when weight goes up, mass is going to go up. Right? Now, how much is it going to go up? Well, that depends on, in mathematical terms, I say it depends on the constant of proportionality. But in the application of physics, the amount that the weight goes up depends on what planet you're on. Now, we're all on planet Earth, right? And so when we talk about our weight, we usually don't talk about what our weight is on the moon or what our weight is on Jupiter. So we talk about this acceleration of gravity being the constant of proportionality. So this actually comes directly from Newton's second law. Weight force is equal to mass times acceleration. But when we're talking specifically about our weight, we're talking about how our mass is affected by the acceleration of gravity. Okay. Just to finish what I'm saying, the question in your notes is, how can your weight change without your mass changing? All right. If your mass changed, you would have to cut off your arm. You would have to cut something off of your body if your mass is going to change. Your body is made up of all the stuff that your body is made up with. If your mass is going to change, you have to remove some part of your body. Now, when you go to the moon, the acceleration of gravity is less, so you feel less weight because there's less acceleration of gravity pulling down on you. When you go to Jupiter, you feel a lot more gravity because the acceleration of gravity on Jupiter is really strong. So when an astronaut goes from the Earth out into outer space, they become weightless because they become removed from Earth's acceleration of gravity, right? And even on a very small scale, if you climb a mountain, you will feel less acceleration of gravity. So you will actually weigh less on the top of a mountain, not by much. You will actually weigh less on the top of a mountain than you would down at the ocean. So the moral of the story is that if you want to lose weight, get high.
What if you take
Okay?